Hello students. So in this video we discuss about the measurement of the electrode potential. How we can measure the electrode potential. So for measurement of electrode potential we use the standard hydrogen electrode or normal hydrogen electrode. Standard hydrogen electrode SHE, or we can represent NHE. N means normal. So what is the composition? What is the basic structure of the standard hydrogen electrode? See this diagram. In this diagram, we take one beaker. In this beaker, we take the 1 molar HCl solution. Listen, 1 molar HCl solution. In this beaker, we put a glass tube which contains two open-ended, and in this tube we fit a platinum wire which is connected with the platinum foil. So what happens? The hydrogen gas is passed through this open-ended hydrogen gas at 1 bar pressure. Pressure is 1 bar pressure. So this is the complete composition structure of the standard hydrogen electrode. In a standard hydrogen electrode, at 1 bar pressure gas is passed into 1 molar HCl at 298 Kelvin. 1 molar means concentration. This represents the standard condition. If the concentration 1 molar and temperature, room temperature 25 degrees centigrade, that is the 298 Kelvin, it means it represents the standard condition. So how the reaction takes place? The main feature of this electrode is that hydrogen undergo oxidation as well as reduction depending on the other metal. If this electrode, if this cell act as the anode, then this hydrogen gas undergo the reaction, participate in the reaction. Hydrogen H2, it loses the electron H positive and converted into H positive ion. How we represent the cell? The cell representation is here. We use the platinum. Platinum means it represents the platinum foil, platinum wire, comma, hydrogen, arrow symbol represented by the slash symbol, and then H positive. But if this electrode act as the cathode, then cathode means gain of electron, reduction. So reduction occurs on the cathode. So in this process, HCl participate in the reaction. From HCl, H positive ion gain the electron and convert it into H positive. Now we want to represent this cell representation. H positive arrow symbol represented by slash symbol, then H2 and comma, then we use the platinum foil. So this is the composition, this is the working function of the electrode, standard hydrogen electrode or normal hydrogen electrode. Another important point in this topic is that the electrode potential of standard hydrogen is taken to be 0. This is the most important point. According to the scientific convention, the electrode potential of standard hydrogen electrode is taken to be considered to be 0. So by using this, we measure the electrode potential of the other metal ion. So other metal ion, how we can represent? So this. So how we can measure the electrode potential? Electrode potential, determination of standard electrode potential of zinc electrode. So if we use the zinc electrode, so zinc is the more reactive metal. So if more reactive metal, then zinc undergo the oxidation and it acts as the anode. And anode compartment, anode beaker is represented on the left hand side. So we take the zinc electrode, dip in the zinc sulfate solution. On the other side, right hand side, we take the standard hydrogen electrode. We already discussed the composition of the standard hydrogen electrode. 1 molar HCl, a glass tube with open ended, fitted with the platinum foil, platinum wire, and this hydrogen electrode by using the galvanometer connected with the zinc electrode. To complete the circuit, we use a salt bridge. This is the general structure to measure the electrode potential of the zinc electrode. Now, how this cell work, how the reaction takes place. Zinc is more reactive, so it undergo oxidation. Zinc act as the anode, it undergo oxidation, it loses the electron, converted into Zn2 plus, lose the 2 electron. At cathode, what happens at cathode? The reduction takes place, and if the reduction takes place, then HCl participate. We already discussed HCl means H positive, it gain the electron, but here the 2 electron loss, so we use the 2H positive, 2 electron, and it converted into H2. These reaction takes place during this process. So during this process, this reaction takes place. Now these are the reaction representation of cell. The zinc, Zn, arrow symbol, slash symbol, Zn2 plus, concentration 1 molar, salt bridge represented by 2 parallel line. Then H positive, arrow symbol, slash symbol, H2, 1 atmosphere. E-note cell, how we can E-note? Cathode minus E-note anode, E-note cathode minus E-note anode, and these are used as the SRP, standard reduction potential. We already know that electrode potential of the hydrogen is 0, so the complete electrode potential is measured as the zinc electrode. The main question here is that why we use the standard hydrogen electrode? Because standard hydrogen, if we use only 1/2 cell, then the reaction not takes place, means no potential develop. That's why to complete this circuit, to complete the cell, both oxidation as well as reduction are required. And if we use the another electrode other than the hydrogen, then they also produce some potential. So if they also produce some potential, so we are not capable to determine the exact potential of the other electrode. That's why we use the standard hydrogen electrode, because standard hydrogen electrode itself have the 0 potential. Next, another example which is given is the determination of the standard electrode potential of the copper. Now the copper is less reactive. I use the term more reactive, less reactive. How we can determine the more reactive, less reactive? So in the next video, we discuss about the electrochemical series. By the electrochemical series, we can easily find out which is more reactive and which is less reactive. So in this video, you remember that copper is the less reactive as compared to the hydrogen. So copper act as the cathode and hydrogen act as the anode. Hydrogen, standard hydrogen electrode, 1 molar HCl, dip in the platinum foil, the glass tube, platinum foil connected with the platinum wire. Here we transfer the hydrogen gas at 1 bar pressure. Here we take the copper electrode, dip in the copper sulfate solution. These are connected through the galvanometer by using a wire, and to complete the circuit we use the salt bridge. Now how the reaction takes place? Because hydrogen electrode now act as the anode, so hydrogen gas participate in the reaction, it is converted into H positive. The electron which are lost during this process gained by the copper electrode, and copper 2 plus gain the electrode converted into copper. Now the deflection which is shown by the galvanometer, only the EMF produced by the copper, because the hydrogen electrode potential we consider as the 0. So again we represent the cell representation. cell representation, E node cell equal to the E node cathode minus E node anode. Again, I repeat this process, how we can represent the cell. You remember by this A, B, C. A means anode, B means bridge, and C means cathode. Okay, so these are the anode reaction. Anode reaction H2, arrow symbol H positive, bridge 2 parallel line, copper 2 plus, copper. And to determine the electrode potential, we use this formula, E node cell equal to E node cathode minus E node anode. E node cathode means here we use the SRP, standard reduction potential. Here also we use the standard reduction potential. We discuss about this term, standard reduction potential. If copper 2 plus to copper, this is given, and the value given is 0.34 volt. Now we want to understand that this is the oxidation or reduction. Copper 2 plus, see this, copper 2 plus converted into copper, it means charge decrease. If the charge decrease, ion converted into metal, it means reduction, and reduction means this is the SRP, standard reduction potential. And if you want to write the standard oxidation potential, then only change the sign, plus converted into minus 0.34 volt. Again, if this is given Zn to Zn2 plus, and the value given, for example, 1.40 volt. If we want to write the SRP, standard reduction potential, metal converted into ion means charge increase, so this is the oxidation, and if this is the oxidation, so this is the SOP, but we require the SRP, so value becomes minus 1.40 volt, minus 1.40 volt.